archaeology. So even branches 1.3 main branches of anthropology, their scope and relevance: socio-cultural anthropology, biological anthropology, archaeological anthropology, linguistic anthropology. Then in 1.2, 1.3, ethno-archaeology in India. The concept of ethno-archaeology. Even this one also, prehistoric, Paleolithic, Mesolithic, Neolithic, Chalcolithic, Copper, Indian culture and civilization, is it? These are all archaeologically related. Indus civilization, pre-Harappa, Harappa, post-Harappa, is it? These are all archaeologically related. What is archaeology? What is archaeology? Study of fossil remains is known as paleontology. That is different. Study of the biological remains. Bodily remains, fossils. That branches differ. Paleontology. Yeah. Study of tools, artifacts, monuments. Is it? Materialistic evidences. Yeah. That is archaeology. Yeah. See, what is history? Chronological study of historical events. Different. That is different. History is a study of written documents. If anything is written, evidences are available, then that comes under history. If no written evidences, then that comes under archaeology. That means, so before formation of history, that means before script, is it? Some cultures are there. They are known as pretextual or prehistoric. Yeah. Study of the prehistory, prescriptual cultures, that is known as archaeology. Yeah. So, archaeo means old. Antiquities. Yeah. Antiquities means the old monuments, old tools, which have definitely prehistoric significance or even historic significance also, but archaeo means pre. Yeah. Material remains, earlier material remains. So the tools, ornaments, vessels, so on the basis of that, so after extracting that, then we can understand what type of cultures are there in earlier times, how this tool technology gradually emerged, how the social conditions and economic conditions were developed. So that means excavating and understanding, analyzing the old monuments and finally reconstructing the past cultures. That is known as archaeology. In the construction of previous cultures, the ended cultures, earlier cultures, prehistoric. So definitely just excavations and extracting monuments is not sufficient. How to analyze that? To analyze carbon dating, chemical analysis, any fossil, even along with the tools, that fossil evidence analysis, is it? So, even analyzing the soil composition, is it biomass is there? Yeah. Some pollen grains are there. What are the pollen grains? This pollen grains belongs to rice. This belongs to wheat. This belongs to some another. Is it? In flowers, pollen is a male reproductive parts. They permanently stay in the soil. Total flower bioorganic substances will destroy, will decay and going to that means dissolve in the mud, earth. But the pollen grains are almost permanent structures. They are very tiny and tough. Yeah. So, except fire, no question of destruction. So, they are going to preserve in the soil. So, on the basis of that, technicians analyze what type of agriculture was there at the time. Yeah. So, what type of crops they produced at the time. So, even if any fossil remains are available, on the basis of that, what type of animals they domesticated. That means scholars can understand what type of flora is there, fauna is there, what type of animals they domesticated, what type of plants they cultivated. So, what type of tools they used, what type of ornaments they used, what type of political system is there, what type of belief system is there. We can understand on the basis of the material remains. Yeah. Then something is available, then what purpose they used that? Is a very problem to analyze the artifacts. Yeah. So, scientists utilize the present primitive cultures, primitive societies, cultures. Food gather hunter societies are still are there. Yeah. Pastoral communities still are there. Agriculture communities still are there. That means pre-agriculture and pre-agricultural societies even today also abundantly present throughout the world, known as primitive societies. That primitive societies even today using almost old tools. They are using even today rock tools, pebbles, even crude iron tools, vessels. Is it? Even Andaman Nicobar tribal groups, even today they don't know clothes. Today also they are nude. But they use some tools. So then the researchers studied that first primitive tribal communities. Studying of primitive society is known as ethnology. Taking that ethnological or ethnographic information and matching with the world monuments, artifacts, tools, and they analyze it. This tribal people are using for this purpose. That means in earlier times also they may use it for the similar purpose. So that means utilizing the primitive society's information and archaeological information, clubbing together and reconstructing the world cultures, this branch is known as ethnoarchaeology. Ethnology plus archaeology is a combination of these two branches. That's why that is known as ethnoarchaeology. Like that, this introduction it goes on. Yeah. Right, that's it, nothing. Yeah. So that's why we never discuss these branches in earlier. Why to discuss unnecessarily time waste? Right now, archaeology. Sometimes they give short notes archaeology. Is it? Yeah. Or ethnoarchaeology, short notes, 10 marker. Many times, if you observe, is it? Old papers. Yes. Right. Archaeology. Systematic excavation. Systematic excavation and exploration of material remains of past, material remains of past, and reconstruction of ancient cultures is known as archaeology. See, I am repeating. Systematic excavation and exploration of material remains of past and reconstruction of ancient cultures is known as archaeology. Next. Etymologically, ETYMO, LOGICALLY. Etymologically means as per the term. Etymologically, study of old monuments and reconstructing of man's past is known as archaeology. In bracket or direct, whatever you can write. Archeo means old monuments. Lazi means study or science. Next. Archaeology is a study of prehistoric cultures. That is history of unwritten records. That is history of unwritten records. History is based on written documents. But archaeology is based on material remains. Where written evidences are not available. Archaeologists excavate pottery, tools, ornaments, ruins of shelters, rock and cave paintings, artifacts, and many other material remains. Next, to discover, analyze, and interpret old monuments, archaeologists take the support of geologists, chemists, paleontologists, botanists, climatologists, and many other experts. They help in excavations. They help in excavations and dating of monuments. Dating of monuments. Next, ethno-archaeology. Take the heading, this separate. Reason is many times they give this. ETHNO, ethno-archaeology. Ethno-archaeology is a combination of both archaeology and ethnology. Study of tribes, and caste groups is known as ethnology. Ethnology concentrates on culture as a comparative unit. Ethnology studies the culture as a comparative unit. While comparing, they understand the use of different tools and artifacts. It is a branch of cultural anthropology. It is a branch of cultural anthropology. Archaeology is a past tense of social anthropology. Archaeology is the past tense of cultural anthropology. That means study of old cultures and cultural remains is archaeology. Chronological construction of past cultures on the basis of material remains is archaeology. Next, in archaeology, next paragraph. In archaeology, it is difficult to analyze For what purpose? In archaeology, it is difficult to analyze for what purpose the ancient people used the materials which are available in different sites. To solve this problem, archaeologists are using ethnological studies to analyze and reconstruct the past cultures. Ethnoarchaeology branch is based on the belief that present primitive lifestyles reflects the past cultures. Present modern contemporary primitive societies are using same technology, tools and artifacts which are similar that of the past cultures. But it is still unclear how to relate these two branches and how to understand the past cultural aspects. That's it. That means this is a branch developed, of course, is a scientific, but still, is it? But still, it's not clear. So definitely, what are the monuments we are getting through archaeological excavations? Sometimes may not be equated to with the present. Such a tools are not here, or this type of tools may not be there, but maybe some matching. But of course, this branch is very, very useful. At the same time, it's not yet fully developed. It has to develop. That is ethnoarchaeology. Many times they focus this. What is ethnoarchaeology? Single line concepts. Okay, then archaeology and ethnoarchaeology. Okay, then dating methods. More than that, if you want to collect, you collect, but concept that much only. You can't collect more than that. But maybe author names, so that one, this person conducted research here, this person conducted here, this person conducted here. This branch started in this year in the world, in this year in India. Maybe again this person applied this concept to Indian context. Chalega. How much you want to collect, no problem. But 100% they see the core. For expansion, expand as per your will and wish. Yes. Next, dating methods. So, this dating methods are two types. Relative and absolute dating methods. First, absolute dating methods. This absolute dating methods also known as chronometric dating methods. War method. Proposed by De Geer. Dendrochronology. Proposed by Douglas. C14 method. Arnold Libby. Potassium and argon method. Uranium method. So these are different absolute dating methods. Many are there. More than 200 methods are there. But these are the most popular dating methods under chronometric or absolute. War. See, war. So in Scandinavian languages, war means layer, just like a stratum, layer. So war means a layer. The layers which formed in the water bodies in glacial region particularly. See, in glacial regions, so almost in summer, so due to high temperature, glacial melting is very high, then automatically, so heavy water flow through the rivers and finally flows into nearby low-lying areas, water bodies. Then in summer, when water flow is very high, the water brings along with mud, sand, rocks, pebbles, many it come along with the water stream. Then they deposit in the bottom. So something, a bundle layer will form. Then in winter, so sunrises are very mild, but even due to heavy weight, so huge glaciers, no, due to the heavy weight, bottom layers definitely will melt, and even in winter also. So definitely water, it flows, but water flow in winter is very less. So slowly water comes. So along with the water, just tiny mud particles only will come, not heavy flow. If flow is very heavy, so mud, sand, rocks, pebbles, is it? A thick layer will form in the nearby lakes, into which this river or stream flows. Then in winter, a small tiny layer will form above that. Then next year again, in summer, again a huge rock, mud, sandy layer again will form on the top in the summer. Again in the winter, yes, a small tiny mud particular layer will form. Again same, like that, it goes on, repeat, year after year, year after year, year after year. Yeah. Same thing is going to accumulate on the bottom of the water body. Almost after 20,000, 30,000, 40,000 years, this low-lying area is complete, is going to fulfill, then automatically water flows into another low-lying area. Like that, water bodies also have their lifespan. After some time, they disappear. Yeah. So, earlier times, at the time of Miocene and Pliocene, tertiary, when it's going on. So, between, that means Himalayan and Vindhya Satpura, this region, this total region is not there in the tertiary period. So, in the tertiary, due to continental drift, is it? Europe and Asia plate, Eurasia plate, the southern plate, Gondwana plate, these two plates, due to movement, tectonic plate movement, at the time, in between these two plates, a big sea is there, Tethys. So, due to internal pressure, this sea bed lifted toward the top, then finally the tissue formation of Himalayan mountains. Then after formation of Himalayan, from Himalaya to Vindhya Satpura, a deep valley is there, a big valley is there. This totally no North India. North India is not a land. This is the deep valley once. When this high mountain ranges came, heavy snowfall, melting, formation of the rivers, perennial, continuous flowing into this valley every year. So, mud, rock, sands, layers. Then, this complete Himalayan to Vindhya Satpura belt, completely filled by this silt, mud, pebbles, rocks, something. Now, that is the North India. In North India, you can't find out any rocky nature, rocks. Only in Rajasthan, Aravalli. No rocks here. That's why 100% in North India, any construction is a brick construction. But in South India, all primitive constructions are, earlier constructions are rock constructions. Even temples also in North India, they constructed by using bricks only. Nagara style is brick style. But Dravidian style, there's a rock style. They use rocks. Reason is plenty available. Rock. Here, where is rock? This is the valley filled with mud and sand and something. That too, silt, alluvial soil deposits, maximum. That's why this is the wheat belt. These alluvial soils are very, very fertile for wheat cultivation, even rice cultivation also, of course, alluvial belt. But these climatical conditions are favorable for the wheat again. But South India almost 27, 28 degrees centigrade. Such a high temperature is not necessary for the wheat. But for rice, that is essential. That's why South is the rice block. This is the wheat block. But particularly in alluvial soils only, world famous granaries, including in India. So there is a different dimension. So in summer, heavy melting of the glaciers, heavy flow, then a thick layer will form in the base of the river body, that means ocean body, any lake or pool or any water body. Then again in winter, water flow is very slow, so automatically a thin mud layer will form. Then first they select one fresh pond or lake or any water body, fresh one, that means into which still the water is flowing. Then after selecting, they cut vertically, something like that. Top two. Then, for example, this layer indicate this year. Then this layer indicate this is 2000. Okay, 17, 18 not it. Okay. Then this is 2016. Then next layer. This is 2015, something like that. They count back. Then, if any something fossil is available somewhere, any dead body, there may be some chances sometimes. Some animal remains just through water flow, so they reach the bottom somewhere, struck in between the layers. Or human, or any something. So, some chances are there to identify some fossils in between these layers. If they identify any fossil in between, then definitely they can identify the age of that fossil remain or any monument. But chances of getting fossils in these layers, that is very rare, very negligible. But this is the very popular method in polar region. Almost Russia, Siberia, Alaska, in these areas, heavy glacials, almost number of glacials. So every year something. So very popular in polar region, Scandinavian regions. This is one method. War method. Yeah. So such a layers, these two layers, no, one is thick layer, another one is thin layer. Yeah. This thick layer is known as coarse layer. This thin layer only. That means the big layer is known as coarse layer, rocky layer, that indicate summer. This thin layer, tiny particular mud layer, indicate winter. These two collectively known as one layer. Such a layers are known as diatactic wharves. Diatactic wharves. On the basis of this diatactic wars, technicians analyze the age of fossil, but availability is very rare. That only you have to write. War method. So, what is this war method? War method proposed by De Geer. War means layer. The layers which are present in water bodies are known as wharfs. This method is very popular in glacial regions. In glacial areas, due to summer, in glacial areas, in summer, due to high temperature, water flow at heavy speed. Due to this, a thick layer of mud, sand and rocky will form in the base of the water body. At the same time, in winter, due to low temperature, melting of glacials is very low. Due to this, a thin mud layer will form on the quartz layer. These two layers, in bracket quartz and thin, collectively known as a diatactic war. Diatactic war. Okay, next paragraph. Technicians first select a fresh water body into which the rivers are flowing. Then they dig it vertically. Finally, They count the layers from top to bottom. If any fossil remains are available in between the layers, then they analyze the age of that fossil. Okay, then over next paragraph. This method is absolute and very popular in Scandinavian countries. But availability of fossil or any monument is doubtful or rare, whatever. Yeah, rare or scarce, is it? Or doubtful, whatever the terminology. Of course, if any available, then that is absolutely we can. Yeah. So, to get one, how many water bodies we should dig? We can't say anything. Yeah. Okay, then. Again, by using this method, up to 17,000 years only we can analyze the age. In this method, one can analyze up to 17,000 years only. Reason is almost more than 17,000 years means almost the low-lying areas are filled and the stream go to another low-lying area. Then when this entered into here, this is the problematic to understand. Okay. So maximum 17,000 years up to 17,000 years. One seven three zeros. Then dendrochronology method. So this method proposed by Douglas. First of all, this is dendrochronology method is botanical method. Botany is a botanical method based on the annular rings of the trees. See, if you cut any root or stem, we can identify some lines internally. Something we can visit. So these lines are known as annular rings. Annum, year. That means plant produce one ring per 1 year. That's why they are known as annular rings. Annum, year. See, first, this is the botanical method. This method is useful to understand or analyze the age of the wooden monuments. So, even it is also useful to analyze the age of fossil if that fossil is available along with any wooden monument. But wooden monuments must. That means directly it is useful to analyze the age of the wooden monuments only. See, first they select one old tree in that particular location. See, for example, in Harappa. In Harappa, all buildings are constructed by using burned bricks, brick construction. But the doors and windows are made by wood. But that wooden monuments or objects are not available in Harappa. Reason is, Indian soils are highly acidic. That culture flourished almost 3000 years back. Almost 2500 years to 1800 years up to is a golden era of Harappa. There is a mature Harappa. Before that there is a pre-Harappa, after that is post-Harappa. These are not the original. Whatever it may be, that means almost 1700, 1800 years back, almost that culture is ended. In India, due to high acidic, maximum 500, 600 more than the wooden monuments can't exist in the soil. They are going to destroy due to the high acidic percentage of the soil. Due to that only pH levels, low pH level. So due to that reason only in India, even human fossil remains also not available. That means in India almost within 1000, 2000 years, almost the dead body is going to, dissolve and melt into is going to mix into the soil. But whereas in Europe, 5000, 10,000, 20,000, 30,000 years also they are going to preserve safely. Reason is, one side that is in the temperate zone, cool climate, at the same time the acidity of the soil is also very negligible. Due to that, number of fossils are available in European region, not in anywhere in the world. But of course in African region, many fossils identified only in volcanic belt. In volcanoes, sometimes these fossils are going to submerge. Such a fossils are going to preserve safely. Up to now in India, only one Hathnora Narmada, not available human. Of course, some fragmentary skulls, Shivapithecus, again some fragmentary Ramapithecus, of course identified, but not full skeleton, not full structure. Some fragments only they identified. That's why long debate is also on that particularly. Even today that is debatable. Some scholars are accepting that is a human, some scholars are not accepting that not the human. Not only Simmons and Edward. So that is different concept. See, first, if anywhere wooden monuments or old wooden monuments are there, then in such locations, first they select the living tree first, the old living tree. Then after selecting a old tree, they cut it first. Then after cutting the stem, then they take a small thin slice of the wooden piece. Then see in this outer layer is Is it old one or fresh one? The fresh layers will form always in center pith. Is it? When inner new layer form, the outer layer is going to push toward the periphery. Is it? That means outer layers are golden, inner layers are fresh. That means if you select a new plant, living, if you cut it, this here layer, what is that? The inner layer. Plants have a wonderful character if all the plants grown in similar climatical condition, they produce exactly similar links. If we cut all trees which are at present in Delhi, if you observe it, exactly rings are similar. If you cut any plant in Hyderabad, if you observe the rings, exactly similar. In any village, any plant, cut it 100 plants. Then observe the annual rings, definitely similar. Reason is, these trees produce annular rings. Is it? That means the trees which are living in a particular environment produce similar annular rings. That means the annular ring structure, thickness is based on the environmental factors like temperature, humidity, rainfall, something like that. That means if 100 trees in a particular location, is it? So they focus to similar environmental conditions, so automatically they produce similar rings. But the number of rings based on its age. I hope it's clear. It's clear. Then first they select a new plant, that living plant, that to particular old plant. How many years the plant can survive? Maximum. How many years that can survive? When Gautama Buddha got enlightenment, almost 600 BC, is it? Around. Under a people tree, Bodh Gaya, Mahabodhi, the tree is still that's there. Still that's there. That means almost 600 BC means before 1000 years, maybe that may be living, the plant, that means the tree. Is it? At the time itself there is a Mahabodhi. When Gautama Buddha got enlightenment. Now, the 600 BC, the 2000 AD. Is it? That means maximum the people trees survive 4000 to 5000 years plus. Pine trees also survive almost 10,000, 20,000 years also. That means the tree has a very long life. Maximum generally, in general, that's the biggest, tallest tree, maximum it can survive 2000 years around. So generally they consider 2000. No, that is different, of course. Then first they select a old tree first. Then they cut it. Then they analyze the annular rings from inside to outside. Why inside to outside? Inner is a fresh one, dirtier ring. Is it? Outer ring is a old one. Old one. That means, see, they analyze this. This year, that may be straight line. If you observe in microscope, that is almost each and every layer is different. Is it? Again, that layers are similar in all the trees. Understand what I am saying? Yeah. So, this layer may be like that. Next layer may be like this. Next layer may be like this. Next layer, something like that. That means each and every layer is a different, typical, very specific. If you take 100 trees, in all 100, in microscope you can identify similar structure. There's a ring, of course, but under microscope, that may be complete thick one, or some gaps in between, or maybe thick and some gap in between, something like that. How the ring form, that is depend upon climatical conditions. So, the plants, that means trees which grow under similar environmental conditions produce similar annular rings. This is the law, basic law for this dendrochronology. Then, after selecting this, so they analyze the rings. Okay, this last something. So, this is 2017, 2016, something. This may be 1000. Then, this is a monument is there, wooden. Then they select that. So, we should cut that one also. Then we should analyze the annular rings of that also. Then they analyze it again. From inside to outside. Somewhere definitely is going to match. That means, so this ring appeared in 10,000 years, that means 1,000 years back. That means, this also similar. That means, this also arised in 1000 AD or 1000 BC, whatever that one. So then they understand. So inside, if this is the inside, for example, so almost this one is going to, if this one matching means this one also has to match. From where to it has to match. All these lines are similar. All these lines are similar. That means almost the 3, 4 something. That means around 1000, 1001, 1002, 1000 something like this, no? So 1005 in that year, this tree, is it? They cut it, then finally produce the monument. The inner one. So like that, first they select one fresh tree, then analyze the annular rings from inside to the outside, then compare with the annular rings of old monuments, then after matching, they analyze the age of that monument. That means somewhere is going to match all these lines. Okay, from here to it is matching. That means that year the people cut it. Then they produced a monument. perfectly it is useful. Absolute dating we can. But matching is definitely not so easy. Is it? Yeah. So, after this, maybe 100, 2000 years, maybe gap. Then how it is possible? Understand what I am saying, is it? Sure. Again, that wood may be borrowed from other climatical conditions. Is it? Sure. So, 99% in earlier times, in ancient times, no export, no import. 100% they are using the local wood only. So, automatically, of course, it gives perfect result. This is dendrochronology method, annular ring method. Write it then. Dendrochronology. Yeah. Again, if that is pine trees, if there is a pine, particularly for 4,900 years, see, that is, for example, something, they produce almost same annual rings. Every year, almost same. Reason is almost pine in cool climatical conditions, no glacial region. Total almost area same climatical condition, cool temperature. So almost same rings will form as it is. Yeah. Almost for 4,900 years once. Then change. Then again, another 4,500 years again. Then change. That means, in pine forest areas, if any monuments are any available, it's very easy to understand the age of that. So something, the fresh one they collect one first, then compare it. Almost similar. Ekdam change. Change is there mean almost 5,000 years, 4,900 to 5,000 years gap. That means almost 4,500 years once some change is arising in glacial regions. That's why the climatical conditions are also changing for almost 5,000 years once. That's why this annual rings also change for every 5,000 years. Remaining 5,000 years, almost 5,000 lines, same. Then immediately change in the structure. Then another 5,000 years, same. Then again change. Understand what I am saying? Like that, they produce annual rings. On the basis of that also, any wooden monument, then they can understand. So this type of rings are there. That means, so they match first. After collecting something, this fresh one, then another 3-4 also they can take it. So something, this is 10,000 year, okay, 2 only there. This is 5,000, this is 5,000. Another they collect. That is 5,000 years back. That means this is 10,000 years, no? This second line has to match with this. Is matching. Then next line is differ. Then again another they collect. That half is correct, matching. Another half is different. Then again that half. Understand what I am saying? Yeah. So that means first they select one fresh one, something layer, then change. That means this 5,000 years, then 5,000 years, then again something again change here, or only this much only there. So 10,000 years back, tree this one, very old. Then another old one is available there. Here this type of annular rings are there. That means 5,000, 5,000, 10,000 years back these rings are raised. Then again something, these are something like this. That means this is 10,000 back, this is 15,000 back. Then another they collect. So something like this. That means this layers formed 15,000 years back. Then another one something like this. $20,000. That means for every 4,900 years, the ring structures change in the pine trees. On the basis of that, also technicians analyze the age of wooden monuments. Like that, on the basis of this dendrochronology, technicians analyze it. Yes. Write it. Dendrochronology method. Dendrochronology method is a botanical method. This method was proposed by Douglas. This method is based on annular rings of trees. Annular rings of trees. This method is useful to analyze the age of wooden monuments. This method is based on a principle that the trees which grow which grow in similar environment, the trees which grow in similar environment produce similar annular rings. This method is based on a principle or fact that in this method technicians first select a fresh, living, old tree. Then they extract its annular rings. Finally, they compare the annular rings of the fresh tree and the annular rings of wooden monuments. This cross counting back method give a perfect dating. So this is dendrochronology method. Okay, next paragraph. Pine plants, pine trees, not plants, pine trees produce different ring structures for every 4,900 years. On the basis of this, also technicians analyze the age of wooden monuments. It's enough. So even if you want to draw this also. They match it. So this is also pine tree rings matching. This is normal. Is it? Comparing of annular rings. Is a new one. This is the old one. Clear. Okay. Clear. Huh? C14 method. So many times they ask this one, C14 method independently. Otherwise, absolute dating methods. 100% they never ask any particular absolute dating methods, simply they leave that. That's it. 10 marker, 20 marker. Yeah. If there is 20 marker, give the list, then explain any two. That's it. Yeah. Then brief out it otherwise. But sometimes they give C14 method specifically. This is the very, very important method. C14 method is a carbon dating method. Is it? Carbon dating method is a carbon dating method based on radioactivity. This method was proposed by Arnold and Libby in 1950. What is this up to? C14 method is a carbon dating method based on radioactivity, proposed by Arnold and Libby in 1950. In some books 49, of course 49, 50, whatever. See, in atmosphere, C12, C13, C14, these are the 4 carbon isotopes are present in the atmosphere. These are the first 3 isotopes in the atmosphere. So, first 2 is more or less stable, but C14 is most unstable and radioactive. Yes. Then, how this C14 enters into the atmosphere? See, in atmosphere, the major element that is nitrogen. What is the percentage of nitrogen in atmosphere? 78 to 79%, 78.94. Next one, oxygen, 20.93 something, 21%. Next one, argon, 0.9, almost 1%. Next one, carbon dioxide, 0.03. Very negligible one, carbon dioxide 0.03% only. Remaining ppm, parts per million only. Anyhow, nitrogen is the most abundant element in the atmosphere. So, this cosmic rays from universe to number of cosmic rays enters into the atmosphere. Even in sun rays also, UV rays are there. Whenever this UV rays or cosmic rays enters into atmosphere, they release neutrons. What is this cosmic rays? Release high neutrons into the atmosphere. When these neutrons passes through the environment, they collude, bombard with the nitrogen. When these neutrons, when they are passing, when nitrogen came across, it passes through the nucleus of nitrogen. That means, when these neutrons of cosmic rays collude this nitrogen, it releases one proton. and gain one neutron. Then when it loses one proton, then automatically number will become 6. Atomic number will convert into 6. Atomic number is based on the total number of protons in the nucleus, not the electrons. Proton electron number is same up to 20. After that, no guarantee. So total number of protons in the nucleus is the atomic number. That is the atomic number. Then atomic weight, mass, that is total number of protons and neutrons. Now what happened here? Earlier 14 is there, 7 plus 7, one is eliminated, another one is added. That means here definitely mass is 14, atomic weight, at the same time this number is 6. Like that, the nitrogen converts into radioactive carbon C14. Then this C14 reacts with atmospheric oxygen. By reacting with atmospheric nitrogen, it converts into carbon dioxide. That is radioactive carbon dioxide, C14O2. Then plants utilize this C14 in photosynthesis. Then through photosynthesis, C14 enters into the plants. These plants produce food material. Then all herbivorous animals, they eat this. Then through food chain enters into animals. Herbivorous animals directly eat the herbs, this plant material. Carnivorous animals eat that herbivorous animals. Anyhow, through food chain, this radioactive carbon enters into animals. Like that, it enters into different living organisms, including human, all. If that animal is surviving, definitely that eat food material. So gradually, the radioactive carbon continuously enters into human body after death. So this living organism can't take food material, so automatically no question of entering into body, but this is most volatile one, not stable one. It releases beta radiation. What for? To reconvert into again nitrogen. That means gradually the C14 release beta radiations to reconvert into nitrogen. In this process, the C14 release almost 15 beta radiations per 1 minute per 1 gram of mass. If any dead material, fresh dead material, if you collect it, that release 15 beta radiations. If that mass is 1 gram, 1 gram material, that may be bone or flesh or muscle or whatever. Then after 5730 years, this beta radiation becomes half. That means 15 beta radiation will become 7.5 beta radiations. That means if you take at a time 100 grams, then number of beta radiations are 1500. Then after 5730 years, the total number of beta radiations are 750. Half of that. Is it? Then again another 5730 years, this will become again half. That means 3.75 beta radiations. Again for another 5730 years, again this one become into half. That's why 5730 years is known as half-life of C14. On the basis of this half-life, that means for every 5730 years, half of C14 converts into nitrogen. That's why the count also going to reduce. That means here two methods are there again. In the C14 method, two methods are there first. One is counting beta radiation, another one, so finding the ratio of C14 and C12. Two methods are there. So this is counting beta radiation by using Geiser-Muller count. This is the name of an instrument. By using Geiser-Muller count, we can analyze the number of beta radiations. By analyzing the beta radiations, one can understand the age of the fossil. But by using this method, 2002, $50,000 BC up to, one can analyze the age of the fossil. If fossil age is more than 50,000, no, we can't. Not this BC, BP, B for present. That means 50,000 back up to now. Only we can understand, we can analyze. If that is more than that, we can't say anything. But when humans came into existence, almost 3 million years back started this process. Australopithecus 3 million to 2.5 million. Then again Homo habilis 2 million to 1.5 million. Homo erectans 1 million to 2 lakh BC. Neanderthal, 2 lakh BC to almost 40,000-50,000 BC they continued. Homo sapiens, 50,000 to 10,000 BC. Grimaldi, Chancellery, Cro-Magnon. That means this method is useful only to identify Homo sapien only. We can analyze the age of a fossil up to 50,000 before present. More than that, we can't analyze this. That means these all absolute dating methods have number of limitations. But methods are absolute. In war method, glacial regions only. That to finding fossil or any monument is absolutely, is it? Depend upon the availability only, is completely negligible. We can't give any guarantee for that. Completely waste of the time. Sometimes waste of efforts and time and money, everything. Getting is an accidental, that's it. May or may not. We can't give any guarantee. Is it? At the same time, dendrochronology method is useful only for wooden monuments only. That too, is it? If the trees are matching only, the rings are matched, then only. If not, that is also no way useful. Again, this C14 method is also number of limitations it has. By using this, we can understand up to, we can analyze the age up to 50,000 BC only. That means before past only, BP only. That means these absolute methods, of course for name purpose only they are absolute. But they have number of limitations. That's why technicians even today give a lot of priority to relative dating methods, not to the absolute dating methods. Absolute dating methods are there, but they have their own limitations. Here also almost high statistical errors arise. Even almost 150 plus or minus, we can't give any, no guarantee for anything, but 180 years plus or minus, so minimum statistical error only. Again, more than 50, you can't go back. If you go back, number of errors arise. You can't count the half-life. Then again, same to same method, definitely. So due to this cosmic rays release neutrons. When neutron passes through the nucleus of nitrogen, the nitrogen release one proton and accept a neutron. Then automatically that converts into C14. In atmosphere, almost the C14, C13, C12, all these are there, but these animals or plants intake both the C12 and C14. The intake through the air and even through the food also. So, this both enters into the animal body. If they are living, when they are living, in living also C14 is volatile, is going to evaporate. That means due to releasing of beta radiation, this person is going to reduce, but when animal is living, again it reabsorbs. That means up to death, these animals and plants maintain C12 and C14 similar to that of the environment. In environment, if this percent is 0.03, in our body also this is 0.03. If this is 0.000004, in our body also 0.000004 only. That means all living organism maintain this two ratio similar that of the environment. Understand what I am saying? What the percentage, what the ratio between these two in environment, that's going to maintain in living organism body also. Up to the death. After death, they can't observe it. But the C14 converts into C12. Then again C12 converts into nitrogen, of course. That is different dimension again. So we need up to this level only. The C14 converts into C12 in 5568 years. This is the half-life. That means half-life of C14. Two half-lives are there. One half-life, that is 5730 years. We consider this in beta counting, beta radiation counting. In that method, we consider this half-life when we compare these two, C14 and C12. Yes. That means, see, for 5568 years, 50% of C14 converts into C12. That means, if person or animal or plant is living, then this two ratio equal to the atmospheric percentage. Then gradually C14 reduce, C12 increase. Then on the basis of the ratio of these two, technicians analyze the age of the fossil. Understand what I am saying? Is it? They can understand it. They can analyze it. That means one is based on the ratio of C14 and C12. In C14 and C12 ratio, this is the half-life. Another one, the beta radiation counting. In that, this is the half-life. Generally, this C14 release 15 beta radiations if that is a fresh one. If that is just today only died, okay, that bone release 15 beta radiations per 1 minute, per 1 gram. The material quantity also considered. 1 gram bone release that much beta radiations. That is 2 grams, 30 beta radiations. That is 10 grams, 150 beta radiations. That means per gram per minute 15 beta radiations that release. After 5730 years, that number, beta radiation number will become half. 7.5 beta radiation only. Then after again another 5730 years means 11,460 years. So number of beta radiations are 3.75. For next again half of that. Something like that. This C14 method goes on. It's not the one method. Here two methods are there. Sure. So then write it. Sure. C14 method. So some introduction over. Is it C14 method? What is this? carbon dating method. C14 method, also known as carbon dating method, or is also known as radioactive carbon dating method. Is it? Okay. This method proposed by Arnold and Libby in 1950. Okay, then in C14 method, two radiocarbon decaying methods are present. In this, two radiocarbon decaying methods are there. One is counting of beta rays or beta radiation. Second one, calculating the ratio of C14 is to C12. Okay, then first, counting of beta radiation. Cosmic rays release neutrons. When these neutrons passes through the nucleus of nitrogen, nitrogen lose one proton and gain a neutron. This leads to formation of C14. C14 is unstable and radioactive. This C14 converts into radioactive carbon dioxide after reacting with atmospheric oxygen. This radioactive carbon dioxide enters into plants through photosynthesis and finally into different living organisms through the food chain. Next, the fresh bone or muscle release 15 beta radiations per 1 minute per 1 gram of mass or material, for 1 gram of material. After 5,730 years, after 5730 years, the number of beta radiations reduces to half. Due to this, it is known as half-life. On the basis of half-life, technicians analyze the age of fossils. By using this method, one can analyze the age of a fossil up to 50,000 BP. Before present. BP before present. Next, finding the ratio of C14 and C12. Finding the ratio of C14 and C12. In all living organisms, C14 and C12 ratio C14 and C12 ratio is similar to that of the atmosphere. When the object is living, the process of decay is neutralized by absorption of C14 through air or food. When animal die, C14 loses radioactivity at uniform rate. And converts into C12 at a fixed rate. By 5568 years, %, C14 or half of C14 converts into C12. This is known as half-life. On the basis of this half-life, and C14 C12 ratio, Technicians analyzed the age of fossil. Clear. Next paragraph. Carbon dating method has some limitations. First one, the C14 percentage may not be constant in atmosphere. Its production may fluctuate due to magnetic field or solar activity. Again, next point, otherwise. Its standard deviation is 150 plus or minus years. That's it. That means standard deviation means the statistical error. Standard deviation, that is known as, the statistical error may be 180 plus or minus. Then again, C14 percentage, we can't say this is fixed. Thousands of years back, that may be differ. Now that may be differ. That depends on the releasing of cosmic rays. So colliding, bombarding. Then again, the earth not only rotating on its own axis from west to east, not only revolving around the sun, the earth is rotating on its own axis from north to south also, like this. One day North Pole will become South Pole, South Pole become North Pole. Is it? What we call, this is the east, west, east will become west, west will become east also. Spinning, not only like this, even like this also. But in geography we study the rotation and revolution only. That's not this movement. This movement is very slow. It takes millions of years. When earth came into existence, the axis is straight line. Now earth axis is not straight line. How much inclined? 23.5 degrees inclined toward the east. Just 2004 tsunami, due to that tsunami itself, the earth axis 0.5 degrees tilted toward the east. That much powerful, that one. That means many factors disturb the earth axis, earth magnetic power. That means many obstacles are there. Need not to go into deeper, but of course this is the scientific method. This is scientific method. So 180 plus or minus it gives. At the same time, atmospheric percentage of C14, we can't give any guarantee for that, but approximately it maintains. That means statistical errors arise, of course. Then potassium and argon method. See, this potassium and argon method is useful to analyze the age of rocks, earthen layers. That's it. Is no way useful to analyze the age of either monuments or fossils. This potassium argon method is useful to analyze the age of rocks and earthen layers. See, this potassium, again in potassium, K39, 40, 41, many are there. K40 is the most unstable and radioactive one. Many isotopes, is it? 39, 40, 41, 3 isotopes here also. Whatever, forget that, we won't bother. So, this K40 is a very radioactive and unstable. This K40 maximum present in lava, volcanic lava. When this magma, when that is it molten rock material fluid, when that is inside the earth, that is known as magma. When it comes out, that is known as lava. Is it? When it exposed to air, then that is lava. When that is inside the earth, the crust, then that is definitely magma. Whatever in that magma and lava, this K40 abundantly present is a molten rock material. Know this one. After coming out, definitely in that magma, all gases, airs, minerals, metals, everything is there. A to Z are there, including gases. But after entering into air, in this molten, this is completely melted rock fluid, that one. So automatically the air, this argon, potassium, something, that argon, something, the gases enter into the atmosphere. Then it remains only potassium. That means all elements, of course. But absolutely this argon is absent in lava. After coming into air, so this argon air, this one, it enters the atmosphere. That means lava is totally argon free, but potassium rich. In the process of solidification, when it's going to solidify, converts into rock, in that process, the potassium converts into argon. Almost 50% potassium converts into argon in 1330 millions of years. That means its half-life 1330 million. That means argon is completely nil in the beginning. Whatever the percentage, that may be differ from one volcano to another, maybe, of course, but the first percentage is 1:0. Potassium argon percentage. Is it in the lava? Then after 1330 years, if this is 100 grams, this is 50, that is 50. That means the potassium and argon ratio become 1:1 after 1330 millions of years. Is it? Then after another 1330 million, that means 2660 millions. Again, half of this converts into that. That means in the beginning 100 grams here, 0 here, 1:0. Is it? Then 50-50, 1:1. Then 25-75 means 1:3. Like that, on the basis of the ratio of this potassium and argon, technicians analyze the age of the rocks and the earthen layers. Something like that goes on. See, this is a volcano, volcanic crater, something volcano. It flows and something, a thick layer will form. Then millions of years, no half-life. Almost within 10, 20, 30 years itself, the lava solidifies. Rain will come, wind will come, weathering activity. Understand what I am saying? Maximum mud layer will form. Is it? Then plants will grow. Then animal activity, human activity, many will go on. Then on this maximum mud layer will form here due to weathering activity, air, water. Is it? Decaying of plant material, animal dead material, animal excreta, and many other activities. So this igneous rocks may become inner one, outer normal mud layer. So some human activity may be. Humans may construct houses here. So some human, some. Then after some, this volcanoes also sometimes even thousands of years in dormitory. Is it? After 2000, 3000 years again, volcanic eruption. Around some millions of years, volcanic eruption. We can't say. Some volcanoes are active even today, every year volcanic eruption. Some 100 years once, some 1000 years once, some 10 million, 20 million, 30 millions after once. We can't say anything. You studied in, is it? Yeah. So, dormitory period is differ from one volcano to another. Then, after some time, again volcano, outburst, lava, another layer formed. Then again weathering activity, is it? Rain, something, again mud layer will form. Plants, animals, human activity, something. Again volcanic activity will, another layer will form. Like that, number of layers goes on, some millions of years. Deccan traps. What are these Deccan traps? Deccan traps are block soils. These block soils are formed by weathering of volcanic rocks only, igneous rocks only, basalt only. Is it? Sure. That means trap, something, the flow is a trap, something. The liquid like spread something. That's why they are known as Deccan traps. These are all formed by igneous, the volcanic lava only. That means in earlier times in India also volcanic eruption happened. only one volcanic lake in India, that is Lonar in Maharashtra. Lonar in Maharashtra. That means, what is that Lonar lake? The lake is nothing but, crater of the volcano. Is it the mouth? Is not crater, no? The crater of the volcano. So something still, the crater is there. Due to rain, the crater is filled with water. Now we consider that is the lake. That is not the lake. That is volcanic crater, that one. Okay, whatever, something. Even how Andaman Nicobar Islands came into existence, they also volcanic in origin. Volcanic in origin. What about the Lakshadweeps? How they came into existence? Coral in origin. That means, before in Andaman Nicobar Islands, that islands not there. Only sea is there. Sea begged to, when this lava it came out, then automatically certified, then that framed a big fringe-like structure, a mountain range-like, that itself we call now Andaman Nicobar Islands. That's igneous. Earlier, the barren mountains. Is it? So we are not discussing geography here. That means, this volcanic eruption, we can't say anything. Sometimes, some millions of years after the volcano eruption, then some millions silent. Millions of years means huge human activity will arise. In Deccan Troughs, number of villages, number of cities, number of that there. If again volcano erupt, these villages, cities, everything is going to bury under volcano itself. End the matter. If something happened, all these villages, something is going to preserve in between the volcanic traps. Then safely preserve all fossils and something. This happened in East Africa originally. That's why maximum we identified fossils in Eastern Africa on the basis of this method. That's why they call something 2 million to 3 million to 2.5 million. When this fossil survived 2 million to 2.5. Is it the lifespan? That means from here to here something 1330 million years, that one. This is a conversion. Is it? Then first rock they collect it, then identify the ratio of that. Then they understand how many millions back this layer formed. We can understand now that one. Again they analyze this rock. What is the percentage of potassium and argon? Then they can understand how many millions back this layer came into existence. Then again this layer they can analyze. Like that, after analyzing, technicians came into existence. Here in first, this Dryopithecine fossils they identified. Almost this volcanic eruption 3 million years back, another one 2.5 million years back occurred. In between this volcanic tracks, that means lava tracks, yes, some fossils identified. Means at that time this fossil beings are there. That's why they fixed the date 3 million to 2.5. Then again in some another area 2 million to 1.5 million are in between. Again, some fossils identified. Understand what I'm saying? Like that, this method is useful to analyze the age of even the fossil also. If any fossils are trapped between two volcanic layers, then only we can trace the age of that. If volcanic eruption is not there, then no, these methods are no way useful. This method is useful only to analyze the age of rocks and earth layers. End the matter. But if any fossil remains available in between two volcanic layers, then definitely we can analyze the age of that also. I hope it's clear. Is it? Yes. Almost in Eastern Africa, technicians applied this method only. On the basis of this only, they came to analyze that. This is 2 million to 3 million to 2.5 million. This is 2 million to 1.5 million. This is 1 million to 2 lakh. This is 2 lakh to almost 50,000. Something like that. Something like that. Sure. So, this is potassium and argon. Yes. Write that one. Potassium and argon method. Potassium argon method is based on volcanic eruption or volcanic lava. This method is useful to analyze the age of volcanic rocks and the earthen layers. In lava, argon is totally absent, but potassium present abundantly. In the process of solidification, of lava, potassium converts into argon. By 1330 millions of years, %50 potassium converts into argon. Known as half-life. On the basis of potassium and argon percentage, or ratio, technicians analyze the age of the rocks. So, even if you want to write this, you can write this. Sure. Next. Sure. If any fossil or biomaterial is trapped between two volcanic rocks, then it is useful to analyze the age of fossil also. By using this method only, paleontologists analyzed the age of human fossils in Eastern Africa. That's it. Then uranium method. So uranium method, this number of series are there. So uranium 238, 235, is it? Many are available. This uranium also radioactive, no? Yeah. It releases alpha radiation and converts into one form to the another. This uranium 238 converts into uranium 234 and 50% after 4.5 billions of years. Then uranium 238 again converts into lead, Pb 206, 4.47 billions of years. Then uranium 235 converts into lead 207, 704 millions of years. These are the half-lives of this. Is it? Then on the basis of half-life, are they calculated or not? That's it and the matter. Sure. So This method is definitely useful to only if uranium is available in that particular. Where is uranium is available? See, in the land, of course, it is available. If uranium is there, then converts into another. But maybe both are maybe at a time. We can't say anything. That means, see, whenever water seeks into the deep valleys, in that only uranium is present. No thorium, no lead, nothing. Reason is, uranium only dissolves in the water. No thorium, no lead, no nothing. When some water seeps into the deeper caves, then in that, definitely any uranium something in the hill region that dissolves and with water it's entered into the deep cave, then again it's going to solidify due to cool climate. Then after some millions of years, billions of years, then it's going to convert into one form to the another, another form to another, another form to another, something like that. That means almost in any case, if some uranium, that means the water solidified particles, SEEP, S-E-E-P, is available, then only technicians analyze, okay, how many millions of years back here it happened. Then they can analyze the years of, so any human activity there, so that is fallen on some objects, then solidified, then converted into, if that is man-made object is appeared, then how many years back this approximately they calculate. So something like that, this radioactivity, this is also based on radioactivity. Its half-life is something, its half-life something, its half-life something. On the basis of half-life, so the ratio again, percentage, technicians analyze the years of, so that even that may be rock formed in the caves after solidification, or maybe fallen on some objects, so that object is, object millions of how it is not possible. Man almost 3 million back, of course, 3 million back man is not there almost. That is Dryopithecus is there, of course Dryopithecus, Australopithecus, something they are not man, but man characters are there. So 2.5, 2 million to some, so human characters. So definitely if something is there, yes, human activity is there, some rocks, tools, broken rock, on that rock something, 2 million back itself some human activity is here. Yes, on the basis of this only in Europe, they identified primitive human activity in the caves. Yes, some broken rocks are there. In cave, who will break the rocks? Is it? In caves, who apply the fire? Man only. Fire applying, using fire, is it? And some human activity, firing the flesh, that means burning and eating that bones, then after eating, crushing and they throw it, no? So something, how humans eat the bones, how animal eat the bones, differences are there. Yes, they can understand. This is definitely human activity. How many million years back happened? Oh, something happened. If that uranium evidences are there, otherwise, no, you can't say anything. We can't say anything. So, these are the half-lives. So, this uranium method, so creates something, is it? Useful to analyze the human activities in the caves, and even useful to analyze the age of the fossil and monuments also, if any available in the caves. That only. Write yourself. Okay, shall we see tomorrow? Absolute methods are over. Then shall we see the relative methods tomorrow?